Guys, welcome. Let's go ahead and start our Go Formative study guide. The angle measure of an equilateral triangle will all be, this is the actual degree amount for each angle, is going to be 60 degrees. All the angles are congruent. If you do 60 times 3, you get 180. The best name for a triangle with a measure of 45, 90, 45 is, we want to use both pieces. The 90 is going to tell me it's a right triangle. And the 245s mean we have two congruent base angles, which means I have congruent sides, so that's going to tell me it's an isosceles triangle. So right isosceles. Number 3, a triangle blank triangles have one angle that is greater than 90, and the other two are less than 90. If it's greater than 90, then we know it's going to be obtuse. Okay. Given ABC is congruent to PQR, what is congruent to R? R is going to be congruent to C. For ABC, find the angle opposite of BC. So if we're looking at this, we can draw a quick little triangle. ABC, opposite BC is going to be angle A. The interior angles of the triangle will have a sum equal to 180. That's the triangle angle sum theorem, where all the angles add up to 180. The legs of the right triangle are AB is the hypotenuse, so it's DB and AD. Have to use two things for a side. The vertex of, or name the vertex of ABC. ABC here is an isosceles, so the vertex is A. But we have to use 3 letters, so we're going to do B, A, C. The base angles are going to be right here, and we're going to have to use 3 letters, so that's A, B, C, and angle ACB. Okay. So for number 10 here, draw BLT. Basically, they're giving me all 3 angles, so I don't need to actually draw the triangle here because I know all 3 angles are going to add to 180, so we just need to go ahead and show that. X plus 42 plus 3x minus 18 minus 2x plus 134 should equal 180. I want to go ahead and combine like terms. X, 3x, and negative 2x is going to give me 2x. 42, negative 18, and 134 is going to give me 158, which equals 180. I'm going to go ahead and subtract 158 from both sides to give me 2x equals 22, and x equals 11. For question number 11, we're going to go ahead and get angle measures. The first thing you notice, though, these angles are congruent. So when I write 2x plus 49 for that angle, I'm going to write 2x plus 49 for this angle, and 5x minus 53 for this angle. Once we have all 3 angles, we know that the angles are going to add up to 180. So we're going to go ahead and solve for x. 2x plus 49 plus 2x plus 49 plus 5x minus 53 is going to equal 180 degrees. Combine like terms, and we're going to get 9x. This is going to be plus, I don't know this one off the top of my head. I knew the other one. This one's going to end up being 49 plus 49 minus 53, which is 45, equals 180. Subtract 45, and we're going to get 135. So 9x equals 135, x equals 15. That is not my final answer. What I want to go ahead and do is plug that back in for p. So we're going to do 2 times 15 plus 49. And if I do that correctly, I should get 79 degrees. Okay. This next problem we can do a couple different ways. 33 goes for angle A, E is 68 degrees, and then AEG, this angle out here, is 45 minus 23 degrees. I'm going to actually use I don't have to solve for x here right away. I can actually cheat the system because I'm only finding these two. If I wanted to solve for x, I could. 68 plus 45x minus 23 equals 180, and I could solve for it that way if I want to. But instead, I'm going to actually go ahead and just say, hey, AEG is this angle out here, so 68 plus what? Well, it'd be plus 112. So if I added those two together, I'd get 180. So I knew they're a linear pair, so I didn't really even have to bother with that. It just saves me some time. ABC is equilateral triangle, where AB is 3x minus 13, the perimeter is 33. Well, if it's equilateral, we know all the sides are congruent. So I'm just going to do 3 times 3x minus 13, which would equal 33, because I just have to multiply all sides by 3. I'm actually going to divide the 3 out right away to give me 3x minus 13 equals 11. Add the 13 over, and we get, that's going to be 24. Divide by 3, and we get x equals 8. This bottom one is probably one of the hardest questions we have. We need to draw 2 triangles to help us out in making all of our answers correct. Here we get D, E, F, and triangle LKM. And we know the corresponding parts are congruent because these 2 triangles are congruent. So that's by CP/CTC, I know this. Let's go ahead and fill in our information. We get this to be 9x minus 61. We get 39 here. L is 5x plus 3. And then we get 14y minus 12. Okay, well right away I see that these 2 line up right here and here. So what I can do is set those 2 equal to each other to solve for x. Okay, and doing that, I should actually come up with x equals 16. Okay, once I get x equals 16, it doesn't really help me. I want to find m so I can match it with 14y minus 12. Well, if I plug 16 into here, I'll actually get 83 degrees. So this would be 83 degrees. If I add those 2 angles up, subtract from 180, I can get this angle here, which is 58 degrees. And now I can match up 58 and 14y minus 12. So for that equation, we'll go ahead and write that 14y minus 12 equals 58. Y would end up being 5. That one's kind of a tricky problem that we had to go ahead and break through all the different pieces in order to solve. All right. Number 15, we're trying to prove triangles congruent. We can only use one of our 5 methods, so I'm going to actually write them all up here real quick, just so we remember them all. If it's not one of those 5, then the triangle is not congruent. So let's go ahead and put in the information we know. TE is the midpoint, or sorry, T is the midpoint of KE, so these are congruent. And KS is congruent to ES, and then this one's congruent by reflexive. So this is going to be side, side, side. And then KTS is going to match up with ETS. T is the midpoint of AU. Notice AU is right here. T is in the middle of that, so these segments are congruent. But is T in the middle of CG? Doesn't say, so I can't mark it. But it does tell me that G is congruent to C, and then I know that I have vertical angles. Notice if I look at one picture, the side is not directly in between the 2 angles. So this is actually angle, angle, side. Okay, so reason why, angle, angle, side. And then cat. Notice C matches with G, so I'm going to write G. A would then match with U, and T is going to go with T. The 2 triangles are right triangles, so we have a 90 degree here, and they share a side, but that's all I know. I don't have, this is not an isosceles that I know of. I don't have any other information. I only have 2 things, so I'm going to go with not enough information or not congruent. LD bisects RE, so here's RE, so these 2 segments are congruent. Didn't say anything about LD getting bisected, so I can't prove that. I do have vertical angles, and then parallel lines help me find alternate interior angles. So I can do these angles here, And if I do these angles, I get angle, angle, side, or I could have done these angles as well, and I could have got angle, side, angle. So this one could be both. It could be angle, side, angle, or angle, angle, side, depending upon how you solved it. And then DRK, D is going to match up with L, R is going to match up with E, and K is going to match up with K. Last but not least, C is congruent to R, A is congruent to U. Notice how I'm using double curves. It never said that AU was congruent to CR, so we have to make sure we're using double or triple ones. And then V right here is vertical. We're going to set those equal. So here I have AAA, but as I wrote at the very top of my paper, these are the only methods we can use. I don't see AAA, so when I get down to 19, I'm going to go with not possibility. That doesn't work, so we're going to say not congruent. Last thing are two quick proofs, and in our proofs, when we're doing these, we want to go ahead and make sure we plug in all of our information. D is the midpoint of both the segments, so now that we know it's both segments, we can go ahead and show both are congruent. We didn't get to do that in our other picture. And prove KT is equal to RG. Well, before we could prove this, we got to prove the triangle is congruent. So I have two sides, and then I also have an angle vertical. So let's go ahead and fill this out. D is the midpoint of TG. That's given. TG is equal to DG. That is going to be depth of midpoint. D is the midpoint of KR. That was given. KD is congruent to DR. That's definition of midpoint. KDT and RDR, that's vertical angles theorem. And then our triangles are congruent by, this would look like SAS. Let's just double check we proved everything. This would be a side, side, and then angle. So we have all of our components. So this is SAS. If we look at our order up here, and then once we prove a triangle congruent, we can prove a second piece is congruent, a corresponding piece, by using CP, CTC. By the way, very important you know what this stands for. Wink, wink, nod, nod. Okay, let's go over it one more time. Corresponding parts in congruent triangles are congruent. Make sure you know that. Just wink, wink. That just says wink. Okay. Now we look at this second proof. P is the midpoint of KT. Now we only know that K, P, and PT are congruent. H and G are congruent, which is great. And then we also have our vertical. So this looks like angle, angle, side. P is the midpoint of KT, given. KP is congruent to TP. That's definition of midpoint. H is congruent to G, given. These two angles are congruent by vertical. And the two triangles are congruent by angle, angle, side. Alright guys, that's it for the video. Hope you enjoyed. Hasta luego.
is easy.